surface area data. So surface area data is also called as the BET, which is commonly used to evaluate the gas adsorption data and generate a specific surface area, which is expressed in the form of area per mass of sample, that is meter square per gram. Okay, so 1 gram of the adsorbent of the prepared nanomaterial will occupy how much area. So this is also sometimes called as specific surface area or BET surface area. Okay, and is expressed in units of area per volume of the sample. Okay, and the surface area of a powder is estimated from the amount of nitrogen adsorbed in relationship with its pressure at the boiling temperature of liquid nitrogen under normal atmospheric pressure. Okay, and the observations are interpreted following the model of BET method, which is also called Brunauer, Emmett and Taylor. Okay, now we will see how to interpret data. So this is an Excel file. Okay, we have, okay, now this is kind of data which we get from the BET. Okay, BET analysis. So first of all, what we have to do is import the data. So we have first of all, on the axis we are putting the relative pressure, which is called the E by P naught. Okay, this plot below, it will be called as N2 adsorption, desorption, isotherm. Okay, now here we are going to paste. So first step will be the import of the data. So what we have to do is take this data and paste here. Okay, then we would paste this data. So we will just copy and paste here. Now what we have to do is to take this and plot. So in case of plot, we would be taking line plus symbol. Okay, so this is our plot. You can make alteration, you can make it bold if you want, you can change here also. Okay, and to show a frame you can just, now if you want to import, you can import. Already I have shown in my many videos how to import export a graph, so you can export it. Okay, so for exporting we have to use TIFF, and then you can name the file, and then you can specify the folder where you want to store the graph. Okay, so this is you have to do. Okay, now similarly there are other data also. So we are going to show the the plotting of LDH with cellulose LDH at different loadings of the nanocellulose. So we have here 1, then 2 and 7 plots to show in one. So I showed you 1, so you have to import your data and plot like this. Okay, so to make a clarity, you have to plot all the plotting all of the different nanomaterials into make different plots. Okay, and then you would be pasting here. So after making the plots, what we have to do is concatenate or merge all the, already I have made a video for how to merge a graph. So this is my total plot. Okay, after this there is one more thing, we have to also make a table. So first of all we have the nanocellulose, and we have the LDH, and then we have the different loadings of the LDH with CNC, okay, or nanocellulose. Okay, now in this one, first of all we have to take the BET data for volume and pore radius. So BET data, if you see the table here, so here we have the BET data, so we just have to copy and paste into the Word file. Now we have the pore volume. So for picking the pore volume, so the pore volume here is 0.0034. This is my adsorption pore volume and desorption pore volume. Okay, so what we need to do is, okay, this is for the different loading. Okay, so this is CNC1. So let us check the value what we have put here. So this is 1.018. okay, so what we need to do is, this is 1.016 plus 0.941. the pore volume is 1.018. Okay. Okay, so we have to take this one. So this is 1.019. Okay, now similarly, in case of pore radius, we normally take the average. Okay, so let us scroll up. Okay, so this is our pore diameter. So this will be the half of this one. So if you see here, this is half. Okay, almost half. Similarly, we can check the other file, for example, for the nanocellulose. Okay, the nanocellulose also in a similar way you will make plots. Okay, now for the nanocellulose, the BET surface area is 2.19, which is similar to here. Then the pore volume is 0.00426. Okay, now so it is almost analogous to the file I have here. Now pore radius, we need to go up. So this is my pore radius, adsorption and desorption. So the pore radius here is 2.99, which is half of that one. Similarly, we will check just in one file and then we will discuss the write-up. Okay, now let us check the last one. Last one, you can see the surface area is, the BET surface area is 8.73. Okay, now the pore volume is equal to 0.0598, so which is almost equivalent. Now let us check the pore radius. So pore radius is equal to, here is equal to 13.70, which is almost equivalent. Okay, now let us see the write-up here. So in the write-up, first of all, this is the general line we have to write in all the research papers. Okay, which is that the surface area analysis was done by the BET equipment, and we draw nitrogen N2 adsorption desorption isotherm. Okay, and this is shown in the, or you can say described in the figure, and all the results are tabulated in the table, which is shown below. Okay, now you can see here all the materials are showing the type 4 isotherm. So we already talked about the type 4 isotherm, which is according to the IUPAC classification, in which we have the finite multi-layer formation corresponding to complete filling of the capillaries, and the adsorption terminates near to a relative pressure, P by P naught, which is equal to 1. And these type of isotherm are obtained by the adsorption of water vapor on the, for example, on the activated carbon at 30 degrees C. And the type 4 isotherm is particularly given by the Mesoporous adsorbents, and this adsorption here in Mesoporous is determined by the adsorptive interaction, and also by the interaction in the molecules in the condensed state. Okay, now we have here we are comparing the surface area of the prepared magnesium aluminum layer double hydroxide with the cellulose and the cellulose magnesium aluminum LDH. So we have coupled and make the LDH. So now you can see here the surface area of the pristine cellulose is very low, which is 2.19 meters square per second, and the surface area of the LDH is 9.23. Now there is a significant you can say an increase in the surface area, okay, which is because of the coupling, or you can say the synergistic effect of the cellulose or non-cellulose with the pristine LDH. Okay, there is a you can say a prominent increase in surface area of the first prepared cellulose LDH, which is 101.927. Okay, and we all know that what does the surface area mean. So it will mean that there is abundant availability of the dynamic sites for the adsorption of any kind of organic or any kind of pollutant that we are going to target. So surface area is decreasing by the increase of LDH. So you can see here in the table, we already talked about the plots. Okay, so in the table you can see here that the surface area is decreasing with the loading of the LDH. So the last LDH surface area is almost analogous to the pristine LDH. Okay, although it is greater than the pristine nanocellulose. Okay, now we can also see here that the highest surface area was of the first LDH. Okay, and we all know that when the surface area will increase, okay, if you see here the nanoparticle which is having higher surface area is having the higher pore radius as compared to all the the nanoparticles. Okay, also the pore volume is also higher here. Okay, so this was all about the expression. You can see the lower pore size and pore volume, the composite of high content are associated with the coverage of the surface with the magnesium aluminum layer double hydroxide. Okay, so don't forget to like and subscribe.